All right, Algebra 1, so welcome back to the examples of graphing our parabolas. And if you can print out this page, that's great. If not, it would always be great just to kind of copy down what we have. So I want you to go ahead and I want you to highlight a few things. Number one is that when you are graphing a quadratic, remember that that's degree number 2, you create a parabola, and that parabola is that U shape that we see. Now, the leading coefficient tells us if the parabola is opening up or down. Now, if it's positive, as we can see here on the first example, it opens up. When there's a negative leading coefficient, it's going to go ahead and it's going to go down. Now, this note page tells us a lot about what we talked about on the first set of notes. Your axis of symmetry, right, is x is equal to a number. Now it's x is equal to negative b over 2a, and then you plug in that value to get the y coordinate for your vertex. These roots that you have, also known as your solutions or your zeros, is that you can plug in y for the equation and solve using any of the 4 methods that we know. Now, your y-intercept is probably the easiest because your y-intercept is always that constant, or what happens when you plug in 0. Okay, so for the next part, you're more than welcome to just go ahead and watch, but if you want to, you can copy these into your notes. So example number 1, y is equal to x squared minus 6x plus 5. Let's first take a peek at this leading coefficient. So this leading coefficient at the beginning is positive, meaning that we're going to go ahead and that this is going to open up. It is going to be a minimum. Every time it opens up, it is a minimum. And that's all because it is a positive up there. Okay. Now we can go ahead and we can move on to our y-intercept. Now our y-intercept is our constant, or when x equals 0. So it's going to be this last part in that in that standard equation. So for us, our y-intercept is the point 0, 5. And I'm going to go ahead, once I find out some piece of information, I always like to start graphing because you don't want to end up later on going back to your graph and filling these things in. Okay, I'm actually going to go ahead, I find it easiest to jump down to my vertex. So I'm going to jump down here to my vertex and then we'll come back to our roots. So to figure out my vertex, I need to figure out my line of symmetry, which is that x is equal to negative b over 2a. Now for us, that would be that x is equal to, we have negative 6 over 2 times 1, meaning that x is equal to positive 6 over 2, x is equal to 3. All right, so this is actually my line of symmetry, which is right below us. We can go ahead, we can fill that in right away. But I need to figure out my y value, meaning that I know that this goes through the point 3 something, and I'm trying to figure out what that something is. And we can go ahead, we can plug in. I'm going to switch to a darker blue to show you that we're plugging this in. So y equals, and we have 3 squared minus 6 times 3 plus 5. So we have 9 minus 18 plus 5. So we have negative 9 plus 5, which gives us to a y is equal to negative 4. So this is, our vertex is at the point 3, negative 4. So once again, once you have a point, 1, 2, 3, 4, please go ahead and graph it on your graph. Okay, now you could go ahead, you could start plugging in values from here to figure out the rest of your parabola. However, if you remember from video number 1, there was relationships that we had. So I'm going to switch over to purple here for some relationships. Meaning that from my vertex, I know you can't see my pencil, but hopefully you're taking your pencil and going from your vertex. I'm going to go 1 to the right, up 1, make a point. And then again, from my vertex, I'm going to go 1 to the left, up 1, and make a point. So that's my first relationship. Now from here, I'm also going to go, I know that things are being squared, so I'm going to go over 2, up 4, over 2, up 4. Okay, and then I go from my vertex, again, always from your vertex, over 3, up 9. Again, that was from my vertex. And it actually ends up being the same point as we graphed with our y-intercept, so I'm not going to graph that again. Now, if you keep going in this pattern, if you'll notice, if you go over 4, so from my vertex, I'm going to switch to a highlighter here, go a little bit lower. So from my vertex, I'm going to go 1, 2, 3, 4. Maybe you can guess that if you, from your vertex, you can go up 4. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You would end up going 16 up there. Now, that doesn't fit on my graph, so we don't have to graph it for us. You only have to graph what's on your graph. But we have some lovely curves that we can go ahead and attach here with our pencil. And you just graphed a wonderful parabola. Please make sure that you add some arrows on there to show that it's going on and on. So we still have a few things that we need to fill in here on our graphic organizer. I always love to fill in this domain right away because I know that my domain for every single parabola is from negative infinity to positive infinity. And the next thing I like to jump to is my range because I know that my range is going to include that y value of my vertex. And so y has to be greater than or equal to -4. Now my very last thing are my roots. So let's do roots in this peach color here. Now you can go ahead and you could kind of look at your graph here, but I'm going to give you a heads up is that sometimes they're not clear points. So what we need to do is that we need to solve for it. So 0 is equal to x squared minus 6x plus 5. I'm going to go ahead, I'm going to factor this. Sometimes you might have to choose a different method to solve. So I have 0 is equal to x, I have a -5, x, -1, that's going to multiply to 5, add to -6, meaning that 0 is equal to x minus 5, 0 is equal to x minus 1. There's one of my points. So my 2 points here are 5, 0, and 1, 0. And if we go ahead and we check it on our graph, those exactly where it's crossing the x-axis. So these work out perfectly. Now, in terms of your root-intercept form, here's a cool little trick, is that you can take this factored form here. Oopsies, that's not a very, we'll switch to a bigger highlight. This factored form and then just set it equal to y. So for us, it would be y is equal to x minus 5 and x minus 1 for your factored form there. So that's your example for your graphic organizer. We have one more video with other examples if you need them to complete your homework.